Hey everybody, here we have another one of those Hypro HP-D3057F3R power supplies, and these are notorious for having failed TPO capacitors in them. Out of all these I've gotten, only one had capacitors that had not failed, and that's because it used a brand other than TPO. But anyways, this one's slap full of them. Practically the entire secondary side is littered with bulging TPO capacitors. So that means we're going to do a recap on this thing. So what I'm going to do here is take the cover off and have a look inside. Now obviously you want to have a switch mode power supply unplugged for quite a while before you start messing around inside of it, because the primary caps can store voltage for a while, and they take a while to be discharged by the bleeder resistors on the primary side. So you always want to be careful about that. So what I'm going to do is I'm going to try to do a recapping video on this power supply once I get inside it. Okay, I've got the screws taken out of the casing. And I figured before I take the cover off, let's have a look at the spec label. And pause to view specs. Other than having issues with capacitors, this is actually a pretty good power supply. It's rated for 300 watts, but let's see, Hardware Insights, I believe is the name of the website. They have load tested this thing and determined that it can do 350 watts reliably. And this is a load tested scenario with scope readings and everything, and the power supply was doing 350 watts, no problem. They actually got 400 watts out of it, but it would shut off from overheating. But definitely a decent power supply, especially for something you would find in like HP computers. But anyways, now that's being said, let's go ahead and pull the cover off and have a look inside. I figure I'm just going to skip the view through the vent, because there's no sense in where I'm going to be pulling the cover off anyhow. What I'm going to do right quick is I'm going to check the primary caps for voltage, make sure they're dead. And obviously to do that you would measure in volts DC and get you a better viewing angle. You just probe the leads where the capacitors are at, and obviously we're getting nothing at all. So that means this thing is discharged. And if you're not sure, always check to make sure your multimeters cables are plugged into the right connectors and your meter is properly set to DC volts. So anyways, we know this thing is discharged, so we can go ahead and start working on it. Now is a good time to go ahead and plug in your soldering iron, which I'm going to do that now. So that way you have a few minutes to heat up and everything. Because obviously in order to recap the power supply, we got to take the old bulging capacitors out. Now let's keep in mind, this is going to be a pretty lengthy video because it involves soldering and everything else. I don't think I've done a real in-depth tutorial on how to recap a power supply, so I figured this would be a good opportunity. I did attempt to do a tutorial on the last Hypro power supply recapped, but that power supply was very aggravating to work with because it had so much glue in it. Okay, soldering iron's plugged in. It's going to start warming up. Let's get you a good view of this thing. All those bulging TPO capacitors. I mean, almost every single one of them is bulging. Pretty typical. Though as far as I know, the power supply was still working just fine. I tell you guys, I've recapped so many of these things I done lost count. These and the Bestech ATX 25012Z units also out of HPs and compacts. Decent power supplies. Both the Bestech 25012Z, 312Z, one of the Bestech 12Z models, and these are all decent. Other than having some capacitor issues. And while the soldering iron is heating up, let's get you a good look inside this thing. I blew it out with the air compressor, but there's still a little bit of dust left in it. This is a power supply that came out of that drywall infested computer. Drywall dust infested computer. Actually, I think it was granite dust, from what I heard from whoever I got the thing from. Very, very fine dust. As you can see, it says danger on the transformer. But then again, this thing is discharged, so it's safe to work in. And while the thing is heating up, the soldering iron is heating up, you always want to have some sort of diagram if you recap a certain model power supply pretty often. I drew up a little diagram of capacitor locations for this unit. I've done this, I think, on the last one I recapped. I lost my original drawing, so I had to redo the drawing again. And the good thing about this is if you're out buying capacitors for a power supply, you know exactly what to get. Now in my case, what I do is I use reclaimed power capacitors from motherboards and other power supplies. More or less what's inside here. And basically what I do is, in a switch mode power supply, when you're just working with the capacitors on the output, such as, let's see, your 5 volt, your 12 volt, your 3.3, you can go up in capacitance and it'll actually benefit the power supply in terms of filtering out any any noise. It does help. I always recommend to stick with the same value or go up. Never go down on your capacitance values. Now if it's something like, let's say, a 5 volt standby rail, especially in a power supply that an older power supply that has a 2 transistor design, you want to choose the exact value of capacitor for replacement, because those kinds of power supplies rely on a certain, capacitance to regulate the 5 volt standby rail. But anyways, in these, I typically, where this unit has 2200 microfarad 10 volt caps, I put in 6.3 volt 3300 microfarad caps. Now normally I don't recommend going down in voltage, but seeing we're working with the output rail on this unit, which is either, let's see, where these 10 volt caps are, it's either 3.3 volts or 5 volts. 6.3 volt caps will work just fine. And basically down here I replace the 1000 microfarad 16 volt caps and 2200 microfarad 16 volt caps with same exact values, because that's usually what I have. And for these I replace them with 470 either 10 volt, 6.3 volt or 16 volt caps. Never had a problem. Now of course, when you're recapping, try to choose decent quality capacitors. You probably heard me mention earlier how the previous power supply I attempted to do a video on in terms of recapping, but it was so frustrating to deal with because there was so much glue. That previous power supply was slap full of this glue. It all depends on who is putting the glue in the power supply, I guess on the assembly line. These things are made in China, and it all depends on whoever's working the assembly line the day this power supply rolled down the line. This one is not that bad, so I figured I would do the video on this one. Now I probably won't cover every single capacitor, but I'll cover installing some and removing some to give you a general idea of what it's like. Now my soldering skills are not the best, though they're decent for this kind of application. But I always recommend you do practice before you start actually working on stuff like this. But anyway, soldering iron is pretty much heated up now, so let's go ahead and get started. And final advisory, this video may bore you, it's going to be long. I'm trying not to rush myself in this, because if you rush yourself too much, you can mess up. First thing I'll do is I'm going to go ahead and use my dikes to go in between the capacitors and separate the glue from capacitor to capacitor to kind of free them up. And this glue here is separating pretty easily. Now you always want to be careful when you get near the coils, because there's coated copper on those windings. And you don't want to scratch up an insulation, because then you'll end up shorting things out next time you plug in the power supply. And it's very crucial on the back coil, because the rear inductor coil has multiple rails on it. You might, if you ever look at one, you'll notice how you have the different colored wires on that big coil. For example, you can see how this one has different size wires for certain rails. The bigger wires are obviously for the 12-volt rail, I believe. And you notice they have a different color insulation on them. There's you a good look. Anyways, there's you a good look at those capacitors. One is actually leaking a little bit. Now I'll go ahead and unsolder them and go ahead and get some replacements for this thing. Now I'm going to go ahead and unsolder a couple of capacitors. You can see I got my fingers on this one. Now obviously be careful when you're working with a soldering iron, because you don't want to burn yourself. Common sense will pretty much tell you that, but just had to mention it. Basically what you do is you can take your iron and get it in here and melt one side and start walking the capacitor up. It's moving a bit, so pull this out so I don't overheat the trace. You don't want to keep your soldering iron on the trace too much, because it can overheat it and burn things up. Do the same for the other side. And basically you just walk the capacitor out of the trace. Now of course, if you haven't come up with a schematic sheet yet on locations of capacitors and their values, you want to do this now. And don't forget to note that these electrolytic capacitors are polarized. You can see the negative mark on this side. So that's one capacitor out. Let's do another one. You can't really see this one. You can probably see the very top of it, but you can watch down on the bottom side what I'm doing. I can tell you guys, this soldering iron has seen its better days. It's funny, I got this from Walmart a few years back. And amazingly, it's not made in China. It's made in the United States. As a matter of fact, it's made in North Carolina. Same state I'm in right now. Okay, there's another capacitor. Usually once you break the glue loose from the caps, they come out pretty easily. On this one, even the even the 16-volt 2200s are bulging. The thing with these TPO capacitors, they don't like heat at all. They do not like heat. And these high-pro supplies run pretty warm because they run quiet. And that definitely will cause lower end cheap capacitors to overheat. That one's bulging. Anyways, while I'm at it, there's that senior capacitor. It's out of that Diablotech power supply in the TV box. That was a cap I installed, and even heat got to it. So it comes to show that even quality capacitors can be let down by extreme heat. Okay, I got all the capacitors pulled out, at least the larger ones. Those are the ones I always replace. The small ones you really don't have to worry about too much. It's just ones like these here. And here's what the board looks like without those caps in there. Looks pretty bare. Looks pretty bare. Now that's been done, it's time to go ahead and get the replacement capacitors. Either you can order them online, which is probably the more recommended way of doing this, or if you happen to have some dead motherboards laying around, you can salvage some caps. Let's say from either dead motherboards or power supplies or other things like that. Right here is my stash of motherboard caps. I have power supply components in that ECS box over there. So I always grab, say, 4 of these 6.3 volt 3300 microfarad caps out of this bin. It's a matter of finding the needed things. There's one. Yeah, it's an OST. Probably not the best brand out there, but I've never had problems with them power supplies, believe it or not. There's a Rubicon. I try my best not to mix up brands when recapping. This is personal preference. Though it looks like I may have to in this video. Actually, I know where I got some more caps. I just have to go grab some. Okay, I got some replacement capacitors for this power supply. These 4 here are going to the 12 volt rail, or minus 12 volt rail, depending on location. These 4 are going to either the 3.3 or 5 volt rails. And these go right near the supervisory chip and BWM controller in that area. And of course, now it's time to go ahead and install these capacitors into the power supply. And of course, as I probably mentioned before, we have to make sure we get the polarities correct when we install these things, and of course install the correct capacitors into the correct spots. And of course, soldering iron is heated back up. We got some 401060 lead Rosen core solder. We'll need some of that. So anyways, let's go ahead and get started. And pretty much installing the capacitors is practically in reverse. You can use a soldering iron to walk them back in carefully, and then once you get them in completely, you can add some fresh solder, so that way you have a good solder connection. I'm going to get these. We're going to need them for some of these caps to straighten the legs out, and to cut off any excess if needed. Try to get these legs straight down to where they just go right in to the holes in the PCB. That way installation is a whole lot easier. Practically, we'll go ahead and put this capacitor in, and luckily the holes are perfectly clean, so I can just stick it right in, though it's in a tight spot, so it may take longer than usual. You're not going to be able to see me install this one, but when I get to the end, I'll do a better demonstration of installing the capacitors. Okay, I got most of the capacitors installed, and I went ahead and time-lapsed that portion because you couldn't really see what I was doing for the most part, because some of these capacitors are tucked in way back inside this thing. But there's two left over. I'm going to go ahead and do a more in-depth demonstration of installing those, so we get a general idea of how this works. Basically, I have two capacitors here, and just want to check the leads here, make sure they're not too long, which they're not. And look at my little schematic here. It tells me the polarities and how they get installed, more or less. I'll go ahead and do this one first. So I have to look for the little dot on the PCB. Excuse the wires being almost in the way. But there's a circle around the hole that the negative terminal goes into. And what I'll do is I'll slide that capacitor in there. Sometimes it's not that easy. Sometimes there's a little bit of solder left in there. This one here just went practically right in the holes. So if you want to, when you're doing your power supply, try to clean out those holes pretty good. Usually you can use desoldering braid or a solder sucker. And then what I'll do here is use any residual solder left to try to hold the cap in place. And if needed, apply new solder. In this case I will, because there's barely any left here. That won't be a very good connection. Though some of these had plenty of solder still left on them. Make sure you can see what I'm doing here, since this is the last part of the tutorial. But now I'll go ahead and just add some solder here. And you want to be careful not to leave your iron on there too long. This iron here is only a 25 watt, so it takes a little bit longer than many people would like to do the job. And of course, my soldering skills are not the best. Not the cleanest anyway. Have to do it. Okay, we'll do this final capacitor. Just the same as before. Let me angle the camera up a little bit so you can see better. I want to stand this thing up because this is the last one. You can clearly see the holes on this one, where the capacitor goes. And one hole has sort of a blockage in it, so it's not going to slide right in. That's where you have to use the walking tutorial. I mean the walking procedure. Just walking one leg at a time, slowly but surely, easy does it. And that'll get the capacitor in there. Of course, making sure polarity is correct. Negative side is on this side. Go ahead and insert the capacitor in there. I can clearly see where the leads go. That is a definite plus. One leg is completely unobstructed. The other has a little bit of solder in it, so the negative side is not going in very easily. Try to do so you can see what I'm doing here. Okay. Now in this case we have to be very careful because there is a surface mount, I believe it's a bleeder resistor, or maybe another capacitor, right there next to where this capacitor goes in. All these all these particular Hypro models, this particular model here, I mean, has that little bitty surface mount component there. And if I melt it loose, it's going to be fun trying to get it back where it's supposed to go. That is if I don't ruin the component itself. Okay, we got this final leg here. Go ahead and hit this leg one more time. It was not quite in there all the way. Now it is. And that solder there looks good. And of course right there is the surface mount component. Now we are officially done with installing the capacitors. So that being said, we can go and unplug the soldering iron so it can cool off. And before I wrap this up, I'm going to show you how it looks. I mean, why not? There's the freshly installed capacitors. No more bulging T-pose. Now, you always want to be careful when you're doing soldering, especially in power supplies, because we're dealing with, you know, on one side, potentially high voltage, like 350 volts or so. Go ahead and touch that side again one more time. While the soldering iron was still hot enough. But basically, you have to make sure that, number one, you don't have any little bitty bits of solder, loose solder. You gotta carefully look for that. If you find a piece, get rid of it. I'm talking about loose pieces of solder. I always want to get rid of those because those can fall into other things and short things out. Years ago, it was probably the first time I ever did any sort of soldering inside of a power supply. I decided to replace the the fuse. It was a real cheap power supply. It was kind of one of those just for the heck of it kind of things to do. So I replaced the fuse, and in the process, I got a little bitty piece of solder stuck in one of the ICs. Didn't realize it, plugged the power supply in, bang. So also you need to carefully look at your soldering work, because you can't have solder going across a gap in your traces. I mean, for example, some of these traces, one trace will be like your plus 12 volt output, and the other trace like a millimeter away is ground. You don't want to short that out. Something you don't want to do. For example, here's a loose solder bit. Make sure it's gone. Trust me, it can happen to anybody when they're soldering. And of course, blow them a few times to make sure that you don't have any loose bits left over. Just make sure that nothing is bridging across. And then you'll just put the power supply back together, but you won't throw it into your computer just yet. In my case, what I do is what's called the back porch test. This is just in case you insert a capacitor backwards, or insert the wrong value capacitor, or you short something out, something to let out a nasty smell or let out the magic smoke. You much prefer it be outside than inside, any day. So you, basically what I do is I just take a paper clip, jumper this thing over to start, which is green and black, just start the power supply up. And if it starts successfully, then I take my digital multimeter out there and probe all the outputs, make sure they're within spec. Now of course the power supply unloaded is going to be, sometimes you may have a few rails that are very close to being out of spec or just slightly out of spec. That's normal, because power supplies, especially switch mode power supplies, require some sort of load. to regulate, in all cases just to turn on. That's why if you look on a secondary side of a power supply, you have these dummy load resistors. Here's one, for example. So there was one there, and there's many more in there too. And basically those dummy load resistors put sort of a dummy load on the power supply, so that way if you don't have any load connected, it will start up on its own, no problem. But anyways, from here on out, it just consists of reassembling the power supply, doing the back ports test, and upon completion of that, you can put the power supply back in service. So anyways, this concludes the tutorial on how to recap a power supply. We'll more or less replace back capacitors in a power supply. Anyways, have any questions or comments, feel free to ask, and thanks for watching.